So what we're going to do is solve the system of linear inequalities that we have here. We have x plus 2y less than or equal to 4, along with x minus y greater than 5. So as we know, the solution to a single linear inequality like this is a region in the xy plane. So we're just looking for a region that satisfies both of those solutions. And that region is called the feasible region. I will label that once we get there. So the first thing we're going to do is graph the lines, and even though we could use technology, I'm just going to quickly graph these just by hand here, just for effect. So if I'm looking at this first equation here, the easiest way to graph this is by using intercepts. And if I let y equal 0, I can see pretty easily that x is 4. So what we're doing is graphing x plus 2y equals 4. I'll worry about the less than or equal to in a little bit here. So if y is 0, plug in 0 for y, we get 4 for x. Likewise, if I plug in 0 for x, it looks like I get 2 for y. So the line on the boundary of this region has to pass through 4, 0, 1, 2, 3, 4, and 0, 2, 1, 2. So we have this line right here, something like that. Okay, I'm just going to make this point bigger to make it look like I actually passed through 0, 2. So now we have x minus y equals 5, and I can see that if x is 0, y is negative 5, and I can see that if y is 0, x is 5. So we have another line that I'm going to graph in a different color. I'm going to pick red, I guess. I won't pick red. I'll pick this pretty purple here. So we have 0, negative 5. And we have 5, 0, and it looks like my line is going to go this. Oh, I can't do that, though. Got to undo that. Since this line has a greater than here, that means that the boundary is not included. And the way we handle that is by using a dashed line. So it's going to be really careful to pass through those points. Here we go. Okay. So the solution to this system has to be the intersection of one of these regions here. So there's 4 possibilities here. Here's what I would do. I would first check if 0, 0 satisfies both inequalities. If it does, great. If it doesn't, this is when we're going to try the other thing I'm going to show you here. Now, if I look at this, if I look at my original equations and I substitute 0 for x and y, it works in the first equation. So I encourage you to try that on your own if you like. And if you plug in 0, 0 to the second equation, it doesn't work because 0 is not greater than 5. So that means that 0, 0 can't be part of the solution, which means this left-hand region here is not part of it. So here's what I would do. I would rewrite each equation so that y is on one side. So if I have x plus 2y is less than or equal to 4, I'm going to have 2y is less than or equal to 4 minus x, which means y is less than or equal to 4 minus x over 2, or I'm just going to write it as 2 minus 1/2 x. So what this tells me is that I am below the line. Now here, luckily, one of our lines is solid, one of our lines is dashed, so I know that I'm below the solid line, okay? Which already tells me I'm either here, which I'm going to draw arrows here to show. And keep in mind, we already checked for 0, 0. So right away, we now know. If I have to be below the first line, I know that I have to be down here. So that must be my feasible region, anything below those lines. But I'm going to double check the other one anyway. So we have x minus y is greater than 5. Now what I'm going to do here is I'm going to add y to the other side. And I'm going to have x minus 5 is greater than y, which means y is less than x minus 5. So that means I am also below the dashed line, because that was a dashed one. And as you notice, the region is below both lines. So again, what is this called? This is called the feasible region. And it contains all points, x comma y, that are solutions to both inequalities simultaneously at the same time. Thank you for watching.